Preparing for AWS Infrastructure Engineering at Bank of America interview. You've reached Candy Mentor, and this video is for you. We'll walk through 15 key questions you're likely to face. For each question, you'll see a sample answer, followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. How do you explain the AWS shared responsibility model in a regulated banking environment? AWS is responsible for security of the cloud, facilities, hardware, hypervisor, and managed service foundations. I am responsible for security in the cloud, IAM, encryption, VPC design, patching, logging, and data classification. In a bank, I would map each control to evidence, such as CloudTrail logs, config rules, KMS key policies, and vulnerability reports. The key is not assuming AWS compliance automatically makes my workload compliant. While answering, focus on the split between AWS and customer duties, controls for data, IAM, network configuration, audit evidence, and why banking workloads need stricter governance than typical cloud deployments. Question 2. How would you design a secure AWS multi-account landing zone for Bank of America? I would use AWS organizations with separate accounts for security, logging, shared networking, development, test, and production. Service control policies would prevent risky actions like disabling CloudTrail or creating public S3 buckets. Centralized logging would collect CloudTrail, VPC flow logs, and config data into a locked audit account. Access would come through federated identity, not local IAM users. I would provision accounts through Control Tower or Terraform to keep standards repeatable. Make sure to cover AWS organizations, account separation, SCPs, centralized logging, network accounts, security tooling, identity federation, tagging standards, and repeatable provisioning through infrastructure as code. Question 3. Design a VPC architecture for a production banking application that must connect to on-prem systems. I would place application and database tiers in private subnets across multiple availability zones, with only load balancers in controlled public subnets if internet access is required. On-prem connectivity would use Direct Connect through a transit gateway, with VPN as backup. Routes would be tightly scoped, and security groups would enforce least privilege between tiers. I would also configure private DNS, VPC endpoints, and flow logging to reduce internet exposure and improve auditability. In your answer, talk about public and private subnets, route tables, transit gateway, direct connect, VPN fallback, NAT, security groups, NACLs, DNS, and segmentation for regulated workloads. Question 4. How do you implement least privilege IAM access for infrastructure teams? I avoid long-lived IAM users and use federated roles with temporary credentials. Each role maps to a job function, such as read-only operations, deployment, or security audit. I use permission boundaries and SCPs to limit what even privileged roles can do. Access Analyzer, CloudTrail, and IAM credential reports help detect excessive permissions. For emergency access, I create a monitored break glass process with MFA, approval, and post-incident review. Be sure to mention roles over users, federation, permission boundaries, IAM access analyzer, temporary credentials, separation of duties, break glass access, MFA, and periodic access reviews. Question 5. When would you choose EC2, ECS, EKS, or Lambda for an infrastructure workload? EC2 gives maximum control and is useful for legacy software, custom agents, or strict OS requirements. ECS is a simpler container option when teams want managed orchestration without Kubernetes overhead. EKS fits organizations already standardizing on Kubernetes patterns and portability. Lambda is best for event-driven tasks with short execution times and minimal server management. In a bank, I would also consider auditability, patch responsibility, network isolation, and team operational maturity before choosing. While answering, compare operational control, scaling model, deployment complexity, cost, security boundaries, runtime constraints, and how financial institutions evaluate manageability and risk. Question 6. How would you design high availability and disaster recovery for a critical AWS application? High availability handles local failures. Disaster recovery handles major regional or systemic failures. I would run production across multiple availability zones, use managed databases with multi-AZ, and remove single points of failure. For DR, I would define RTO and RPO first, then choose backup restore, pilot light, warm standby, or active-active. Data would be replicated cross-region where required. Most importantly, I would test failover regularly, because untested DR is only documentation. Make sure to cover multi-AZ design, backups, RTO, RPO, Route 53 failover, cross-region replication, database recovery patterns, testing, and the difference between HA and DR. Question 7. How do you manage AWS infrastructure using Terraform or CloudFormation in an enterprise environment? I treat infrastructure code like application code, versioned, reviewed, tested, and promoted through environments. With Terraform, I use reusable modules, remote state with locking, and separate workspaces or state files per environment. Secrets never go into state or repositories. They come from services like Secrets Manager. I also add policy checks, using tools such as Sentinel, OPA, or Checkoff. This creates consistent infrastructure while preserving audit trails and change control. In your answer, talk about modules, version control, remote state, approvals, drift detection, environment promotion, secrets handling, reusable standards, and policy as code for regulated deployments. Question 8. What monitoring and logging would you enable for production AWS infrastructure? I would enable CloudTrail organization-wide, AWS config for configuration history, guard duty for threat detection, and VPC flow logs for network visibility. CloudWatch would handle metrics, logs, alarms, and dashboards for service health. Logs should stream to a centralized, immutable account with retention aligned to regulatory requirements. Alerts need clear severity, ownership, and runbooks. Good monitoring is not just collecting data. It is making failures actionable before customers are impacted. Be sure to include CloudWatch metrics and alarms, CloudTrail, AWS config, guard duty, security hub, VPC flow logs, centralized log retention, alert routing, and operational dashboards. Question 9. How do you handle encryption and key management for sensitive financial data in AWS? For financial data, I encrypt at rest using KMS-backed customer-managed keys and enforce TLS for data in transit. Key policies should be tightly controlled and separated from application IAM permissions where possible. I prefer automatic rotation for supported keys and documented manual rotation for special cases. Secrets belong in Secrets Manager or Parameter Store, not environment files or repositories. Every key use should be traceable through CloudTrail for compliance and incident investigation. While answering, focus on encryption at rest and in transit. KMS Customer Managed Keys, Key Rotation, Key Policies, Envelope Encryption, Secrets Manager, TLS, and Auditability. Question 10. How would you manage patching and vulnerability remediation for AWS compute resources? I would combine golden AMIs with automated patching. For immutable workloads, I rebuild images through a pipeline, scan them, then redeploy using auto-scaling groups or launch templates. For long-running servers, Systems Manager Patch Manager can apply approved patches during maintenance windows. Inspector and vulnerability feeds help prioritize critical findings. In banking, I would document approvals, test patches in lower environments, define rollback steps, and track remediation against SLA targets. Make sure to cover Systems Manager Patch Manager, maintenance windows, golden AMIs, inspector, vulnerability severity, change approvals, rollback planning, and differences between immutable and in-place patching. Question 11. How do you build a safe CI/CD pipeline for AWS infrastructure changes? A safe infrastructure pipeline starts with pull requests and automated checks. I would run linting, Terraform plan, or CloudFormation change sets, security scans, and policy checks before approval. Lower environments receive changes first, then production requires additional approval and a linked change ticket. Deployment roles should be assumed by the pipeline, not individual engineers. Rollback plans and state backups are essential because infrastructure mistakes can break networks, access, or customer-facing systems quickly. In your answer, discuss pull requests, automated validation, static security scanning, plan review, approval gates, environment promotion, rollback, change records, and separation between developer and production permissions. Question 12. A banking application in AWS suddenly has high latency to an on-prem database. How would you troubleshoot it? I would first confirm scope, which application, subnets, regions, and time window are affected. Then I would check CloudWatch, Direct Connect metrics, VPN tunnel status, route tables, and any recent changes. VPC flow logs and application traces can show drops, retries, or connection spikes. I would also involve network and database teams because the issue may sit outside AWS. During the incident, I would communicate impact, mitigation steps, and next updates clearly. Be sure to cover checking CloudWatch metrics, Direct Connect health, VPN failover, route changes, DNS, security devices, VPC flow logs, packet loss, application metrics, and coordinated incident communication. Question 13. How would you secure S3 buckets that store audit reports and customer-related files? I would start by enabling S3 block public access at both account and bucket levels. Bucket policies would require TLS, KMS encryption, and approved principals only. Versioning and object lock can protect audit records from accidental or malicious deletion. Access logs, CloudTrail data events, and Macie help monitor usage and detect sensitive data exposure. Lifecycle policies should match retention rules, but deletion must be carefully controlled for legal and regulatory records. While answering, include block public access, bucket policies, IAM conditions, encryption, versioning, object lock, access logging, lifecycle policies, Macie replication, and data retention requirements. Question 14. How do you approach AWS cost optimization without weakening security or reliability? I start with visibility, consistent tags, cost allocation reports, budgets, and anomaly detection. Then, I right-size compute, remove idle resources, tune autoscaling, and use savings plans or reserved instances for stable workloads. Storage lifecycle policies can reduce S3 and backup costs safely. I would never cut required redundancy, logging, encryption, or monitoring just to reduce spend. In finance, cost optimization should be governed, measurable, and risk-aware. Make sure to mention tagging, cost allocation, right-sizing, savings plans, reserved capacity, idle resource cleanup, storage lifecycle, autoscaling, cost anomaly detection, and governance guardrails. Question 15. Tell me about a time you handled a production infrastructure incident. What did you do? I would structure the answer around impact, action, and prevention. For example, during a production outage, I first validated customer impact and joined the incident bridge. I checked recent deployments, alarms, logs, and dependency health, then helped roll back the risky change. I kept stakeholders updated with facts, not guesses. After recovery, I contributed to the root cause analysis, added monitoring, improved the runbook, and created a preventive control in the deployment pipeline. In your answer, use a structured story with situation, impact, investigation, mitigation, communication, root cause, prevention, and lessons learned. Emphasize ownership, calm execution, and post-incident improvement. If you are still with us, congratulations. You are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.